Hi students, so I'm making a video for you for the temperature and energy simulation activity. The first thing you're going to need to do is make a copy of the document that goes to the simulation that I made for you. Click File, make a copy, and then you're going to have your own document that you own and you can edit. You can call yours whatever you want, type your name there, uh, and there you go. Click OK, you'll have your own copy. Close out the original. Then you'll have your own copy of the document. I'm calling mine this introduction here. So let's go ahead and get started. The simulation link I've shared with you, it's right here. It's a fet.colorado.edu simulation. Go ahead and click Introduction. And here are your objectives. Be able to describe the relationship between energy and temperature. Be able to describe in words and pictures how energy is transferred between two objects at different temperatures and explain why and when this process stops. Be able to plan an investigation to produce data to support a model of how the system of a hot object and cold object will change with time. Let's go straight to number 1. In the boxes below, draw the model. So instead of drawing, we're going to be doing a lot of copying and pasting and screenshotting. You're going to be wanting to do this in Google Docs. So the problem's asking you to draw the model given in the simulation and draw a model of the molecules in an object when the object is cold on the left and hot on the right. So you could go ahead and do this with the simulation, pick whichever one you want. You're going to want to click on energy symbols, and we're going to go ahead and stick one of these here. Right here it's cold, so it's asking you to just draw a model given in the simulation. This is a model given in the simulation. This is cold. We could make it colder, and you see what happens when you make it colder. The energy symbols are dropping out of it. It should continue to drop out of it until it reaches freezing. And there is a technical, let's see if we click on the thermometer here and stick that in there. Does it give us a number? Strangely, it doesn't give us a number, but then it's giving us relative ID. You can see that the thermometer had gone down a little bit. If we turn the heat up, it's going to go up, the thermometer. Let's go ahead and show that here. You see the thermometer is going up a little bit. Let's bring it back down now. So we're taking energy symbols out of the water. So there's cold. So go ahead and, if you're using Windows, you can use a snipping tool. I like using the snipping tool. Click New on the snipping tool, and there you go. You could do it like that. It should already be copied, but click Edit Copy if you want. Delete this symbol here in your document and paste the new one that you've just created. If you want to shrink it down, you can. Click on it, grab the corner, shrink it down. I always find it best to wrap text. So here's a cold energy model. And let's go ahead and heat it up. Oh, I'm clicking on the picture. Let's heat it up. So you're going to see more energy symbols as we heat it up. And seeing those energy symbols being given off to the air is a really good thing to have in your picture when you go ahead and show the hot object energy model from the simulation. You can perhaps even see faintly in the background that there's some evaporation effects going on. I'm going to go ahead and see if I can get a snipping tool of that. Let's delete our picture again in the document. Paste our new one. Shrink it down if you wish. So that's good enough for what it's asking you to do there. So what do cold object molecules look like? This simulation is not the best for showing you the energy of particular molecules. So what I went ahead and did, I got the link for you to the state of matter basics simulation, and I'm putting that right here in this video. You can go ahead and try and show the cold object molecules versus hot object molecules. And honestly, if you just click off these energy symbols, you might be able to go ahead and get a better image of the evaporative effects that are going on inside of that water container. So you're seeing, by seeing the steam there in the background, you're seeing those molecules with higher energy. Molecules in a gaseous state are at higher energy than molecules in a liquid state. But I think the state of matter basics simulation is really good for showing the energy that molecules can have upon absorbing energy or losing energy. So I went ahead and put that link right here for you, and it opens up this one. You can go ahead and click the states and pick an actual molecule like water. And here you're seeing the molecules all together. When you click their solid state, they have vibrational energy. They have very little rotational energy and very little translational energy. And that makes sense, right? Translational is across the room, left and right. They're not really moving across the room. They're not really moving left and right. That's characteristic of the solid form. They also have very little rotational energy. That's more characteristic of a liquid state. So we're seeing very little translational energy, but we are seeing a lot of rotational energy. So there is some flowing going on, but most of it in a liquid in a container that's just sitting on a desktop. Most of those molecules are rotating in place. They're not really moving left and right. There is some left and right movement going on from airflow that puts energy into them and moves them left and right. But as you can see, rotational energy and vibrational energy are most characteristic in the liquid state here. Let's go ahead and just take a snapshot of this, because I think this was a far better answer to the question for what's going on in our document. Let's click that, copy, go back to our document, cold object molecules, paste, and let's go ahead and get hot object molecules. And if you wanted to show even hotter than that, a gaseous state would be best. So let's go ahead and snapshot that too. And put that in our document. Well, it looks like I took a picture a little too zoomed in there to show what's totally going on. There we go. Edit, copy that. And let's delete that one and replace it. Good. So now we have cold and hot. Let's shrink this guy down a little bit. So this copy and pasting and shrinking down, this is always a lot quicker and easier to do than drawing. When you do this, set these pictures to wrap text, and then you can move it around freely inside of the document. If we shrink this down just a little bit more, we can then move it up into our cell right here. Okay. At the molecular level, what form of energy do molecules have? They have three forms of energy. We can go ahead and delete this blank space. They have rotational, translational, and vibrational. Heat up the brick and iron to the same temperature. I'm going to close out this State of Matter Basics program because it's eating up a lot of my RAM. Let's go back to this question. Heat up the brick and the iron to the same temperature. What differences do you notice? So let's go ahead and put the brick and iron on here. We'll need the temperature gauge. We want to heat them up to the same temperature. We're going to need to see energy symbols. So right there, and you should see some evaporative effects in cooling. Let's get them to the same temperature though. Oh, there we go, that's about the same. So why don't we really quickly set these pictures. Okay, this one is set to wrap text. This one is set to wrap, no, that one's not set to wrap text. Let's move these down and to the left with the down arrow and to the left. And what I'm going to do is copy and paste the pictures of my bricks. It might even be wise to delete this one here, but let's leave it in. So they're still about the same temperature. Let's heat them back up. That's about the same temperature. What do we notice? Well, we see less energy symbols in the brick. That's one thing that we notice. But let's snapshot this and put it in the got that one, edit, copy, paste, and we'll take this one, the brick, okay, so now I have my brick here, I have my iron here. The brick is a little bit lower temperature, but you do see the iron has more energy symbols. So it looks like iron has more energy symbols. It's stored more energy. That's a concept called heat capacity. More likely. Now here they're showing you the same volume of objects. You don't necessarily know if the mass of iron and the mass of a brick are the same. Heat capacity is dependent more on mass and not on volume. So iron probably does have more mass here, and that's why it's able to have more heat up in it. There is also another aspect of heat capacity that is related to the material itself, the atomic or molecular makeup of the object. But here the differences are probably mostly due to mass. If you take a brick of iron and the same volume of brick, the mass difference is probably what's mostly related to the more energy symbols being in this brick of iron than this brick of just a standard brick. All right, what is the temperature of an object measure? Stored heat could be a good example. Stored thermal energy in the molecules. That could be a good answer to that question. You might have one that's slightly different. Put a hot object into the cold water. Draw what happens to the energy in each of the stages. So to do this, let's reset the program. We're going to want cold water. Make it colder. Energy symbols are usually good. Let's cool it down and pull some energy symbols out of it. Let's put the thermometer in it, see where we're at. So that's pretty cold. Now we need to heat up an object. Let's heat up the iron. First thing that we might want to do is take a snapshot. So I'm clicking here on my object, and I'm going to snapshot it. Highlight that. So that's cold. Edit, copy. I'm going to paste it right here. I'm going to shrink that down. I'm going to delete this hot object. And I'm going to take a picture of my hot object. Let's go ahead and put the thermometer on that too. Oh wow, this program's written very intelligently. You can't put the thermometer in a brick of iron. That's very wise. Makes sense. So again, let's put more energy symbols by heating up the iron brick into there. Let's take a snapshot of our iron brick. And I'm going to paste it right here. Now we're going to put our iron brick right into that water and see what happens. So we're seeing energy symbols leave the brick and go into the water. Now the water has a higher temperature. So the water has absorbed some of the energy symbols from the brick of iron. Let's delete this one and replace it with the one we just made. Shrink that down. And as time goes by, what happens to this object? Go ahead and let 30 seconds go by. Then take a snapshot of that and stick it in here. Now I'm telling you to take a snapshot of that. Let's go ahead and do that. I'm going to delete this, and instead of using my snipping tool here that Windows has, if you're using a Chromebook, I've showed you this in earlier videos, but if you're using a Chromebook, you can go ahead and use your print screen feature. I'm going to press print screen when I see another energy symbol evaporate out of the water there. There we go, got it. Now I'm going to go ahead and just paste my print screen. Whoa, what a big picture. Okay, the first thing I'm going to do is click on that. Then I'm going to double click it. And I'm going to shrink that picture down to what I want to have. Grab these black bars, and you can shrink it down to just what you want to have. Keep shrinking down. Keep shrinking down. And then you can click off of it, and it should have a nice shrunk down cropped picture. Make it a little bit bigger to match this one. So as time goes by, you should see energy molecules have left this brick, continued to go into the water, but still the temperature of the water has dropped because it's been evaporating energy symbols to the air. All right, so when and why does the process in number 5 stop? I'm going to leave that to you, but to go ahead and answer, I will give you a hint. There's a word called thermal equilibrium. And if you're just like, okay, what is thermal equilibrium? I'm going to go ahead and encourage you to Google that. In your textbook, there's discussion about thermal equilibrium and when thermal energy transfer stops. But this word equilibrium, you should be thinking about a seesaw coming to rest. You should be thinking about a microwaved cup of coffee cooling down when you take it out of the microwave. Cooling down to what point? You should be thinking about things like that. So now number 7 says plan an investigation in the real world to collect data to test the model from 5 and 6. You're going to go ahead and make a claim. You're going to go ahead and say what evidence can be collected that will support your claim. So what would I think? You're looking to test the model from 5 and 6. Do you have anything in your home that you could easily heat up and drop into cold water? And could you maybe take a picture with your smartphone and put it in here, demonstrating what's going on in number 5 that we've shown? A hotter object dropping into water and somehow depicting that heat has transferred to the water, and over time that water cools down. You could do something like put some water in the refrigerator in a cup. You could heat up something in the microwave. Would be a good thing to heat in a microwave. That little chunk of banana, you could take a chunk of banana and put it in the microwave for about 15 seconds, and that thing's going to get pretty hot pretty quick. You probably want to do that in a coffee cup, and you could pick it up with a spoon. If you tried picking up a chunk of banana that you put in a microwave after 15 seconds, it would burn your fingers. So go ahead and do that with a spoon. Don't do it with your bare hands. There's a lot of molecules that get hot from microwave radiation inside of a banana. And then you could drop that into the water. How could you show the temperature change? You could maybe try and take a picture of this again and demonstrate that the water molecules are moving around more. You could, what other evidence could you put in there? You could perhaps, the cold water that you put in the refrigerator, you could have done this with a control where you put an ice cube in both of the cups, 2 cups of equal amounts of water, put an equally sized volume of ice cube in the water, heat up the banana in the microwave, and drop it in. I might actually do this to demonstrate it. And after, say, 30 seconds, take a picture of the 2 ice cubes and show the difference. With that said, that's just one idea that you could have for this experiment. I'll probably go ahead and make one later. Once you do all that, you're done with this handout. I know this video is pretty long, but hopefully it'll help some struggling students. That's a walkthrough with the simulation of temperature and energy activity. Have a good day.